Hello, hello, test. Cool. Nope. I'm gonna wait a moment. Doot, doot, doot. Okay. I was reading something. Mm, 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 mm. Okay, session counter is going. That's good enough. Okay, so what am I doing? I am building a game. So, what's the game about? The game, so I'm gonna build a Jackbox clone. If Jackbox. So if you don't know about Jackbox, it's a bunch of these party games. Um, the 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 format is pretty simple. You've got this one centralized area where you've got a bunch of different types of games, and you have a host, and the host starts the game. And when you start the game, you enter yourself into this kind of lobby, and the lobby has a man, I wish I had it. The lobby has some room code, and people in your party put in that room code, and they give a name. This is from the last time I played, or messing with my friend Craig, and they can join. They don't have to download anything. So that's kind of what I want to do. When I was doing some research onto this project, I came across a Reddit. Where is it? Came across a Reddit thread, an AMA of the Jackbox the Jackbox user or developers. And where is it? Here it is. So they were able to give a little bit of a description of the technology stack, which seemed like it was really straightforward for the most part. So in their post, they said that they work on, they call their game servers Blobcast, which I don't know very much about. And they were describing it as just a cluster of Node.js servers. So all of their games talk to the players' phones, because that's where this is the controller, that the web app. The people mostly just pick it up, play it on their phones, or they can use their desktops. It doesn't matter either way. It's just if you've got a browser, that's your controller. and all they do is they have their controller hook up to the server, and the server is kind of, it's got the game logic and it pushes everything along. So that's what I want to be able to do. And of course, I'm going to be doing it in Rust because, well, simply I just want some experience doing this in Rust. Oh, it's not on. One sec. Okay. So what we're doing today is just a little bit of planning. Gonna just I've got a repo set up for it. Oh, misbehaving. I can't actually resize this. Yeah, that doesn't matter. So we're gonna do some planning today, and if anybody has any suggestions, I'm hearing it. If you're familiar with any of the Jackbox games, so I described what the basic interaction is. You've got the server, and you got the phone aspect of it, but then you've got the one thing that we don't have is a game. And so I wanted to keep the game really simple, and we're just gonna do like a rock paper scissors. Not really sure, just because like the game logic is really simple, and it might be kind of fun to have the ability to have like a distributed rock paper scissors tournament where you can kind of just challenge people, and we can work on the actual game logic there. But rock paper scissors, I don't know what the name is right now. Untitled stream game, that's what we got. That's what my repo is called right now. So what are we gonna do first? So I wanted to get a bunch of the project management stuff all set up, and I was thinking that one of the first ways I would do that is to get it into some kind of Kanban board, and I just wanted to keep it all in one place. So I'm going to keep it in the projects section of my repo, and let's do that. Let's just call it the projects. So the game development. I don't know what any of that is, so I'm just gonna create it. Let's call this to do. Sure. Automation. Use a preset to enable tracking automation for better context sharing across the project. I'll just leave that here for now. So we're just gonna have a bunch of to-dos. And so I'm gonna actually split these up to a bunch of to-dos for the different domains. So I think that we've got like 3 different domains right now. Oh, actually, I'll just leave that in. I'll just tag them all. So the different domains I see are the server, the client, and the actual game itself. So I will have some so the server I just need to create the server first, the server code. Create the server, create the client. Create the game board. And what are the things? So from the Jackbox things, we need to generate the room codes, and I don't actually know what we're gonna use for the logic for connecting to each other. So I had originally envisioned that we would use GraphQL, but honestly, after reading through this thread a little bit, they don't really describe using anything as complicated as GraphQL. I think they just use WebSockets. And I don't really know very much about WebSockets, so but I don't know very much about GraphQL either. So it doesn't really matter. Let's just determine choose a server, the client server that can I give notes to that? Yeah, not great. WebSockets versus GraphQL. Okay, and so we can go pros and cons to all of that. I'm almost sure that I am going to be creating this with WebAssembly. So part of the client, created the client is build the WASM view structure. So we're just gonna build the U structure, U being the Rust crate. The game board, I don't know that matters too much, but let's just comb through here. So yeah, they use Redis for a bunch of the caching because they don't actually keep very much data as far as I know. Like your games are pretty isolated. So let's play around with Redis. Add Redis. And I guess some of the DevOps stuff I'm going to need to do is just for development. So let's create a Docker Compose for infrastructure. All right. So question, if there's a reason I'd use GraphQL over WebSockets, I don't honestly, I don't know the answer to that. I'm just going off of what is like the new hotness in terms of I don't do any front end dev stuff. So honestly, for me, I just want to do what is the most straightforward, and possibly if there's a standard, I kind of want to do what's standard first until I form an opinion about what is the good thing to do. I know that Facebook uses GraphQL, and so I imagine that there's a lot of support for that. And some of the reasoning behind around doing all this is so that I can reuse some of the experience for the other project that I'm maintaining, where I'm kind of held up on the front end portion of it. So I've got like back end server logic, and I want to be able to have the web client interact with the server, and I'm passing stuff beyond that server client boundary. So whatever is going to be good enough for creating the client, I just want to do that. Good question. Okay. Client. Oops. So the client, I need to be able to connect to server. And what else? The server needs to be able to send state to all of the connected clients. Connected clients. What else? What else? Oh yeah, I need the game logic. Rock, paper, scissors. Put the rock, paper, oops. Why did that happen? Rock, paper, scissors, game logic. Man, this is kind of a weird tool. I'm a little bit used to using Trello, where what happens if I oh man, I do not like that. So one of the things with Trello is you're able to have a title to the note and some kind of coloring, labeling, aspect so that you can kind of visually have things set up, and then you're able to keep notes inside it. So you know, if I clicked it, it would pop out this note, and I'd be able to give a description and then like have comments within it. But it's a lot more bare bones here. Hmm. Okay. Uh. So what is that? So I got a few things here. I know that I can probably get a few of these things done now. But I'm gonna try to do some more design first before I start any of the coding. One of the other things I want to be able to do is play around with Figma. So if you don't know about Figma, it is it's a I know my wife who's a designer. She uses Figma, and other designers I've worked with, they use like either like Figma or Sketch. But I'm gonna try this because it works in their browser, and being in Linux, having a design tool that a lot of people are able to use, such as Figma, and you're able to collaborate at one time using Figma at the same time. It seems like a good tool to dedicate some of my time into getting familiar with. So let's start here. So what I want to do is draw out some of the structure. So ooh, that's weird. So this will be the server, and this is the game. And what else will we have? Know what I want? No. Didn't mean to do that. So the game. We have the server. It's probably going to be more like this. Like that. Okay. And then we've got we'll just call it the server, and this will be a client. So I envisioned that the client will just connect to the game, and the game will just be this in between for the server. How do I draw lines? Arrows. So the client will connect to the game, and the game will connect to, whoops. Game will connect to the server, and the server will have some kind of it needs to know. That's probably where Redis comes in, like a cache. what will I call it? I'll just cash money. And I think I'll call this Redis for now, since I'm fairly certain that's what I'm going to use. And the reason why I would use Redis over whatever is, well, for development reasons, I can run it locally. It's free, and it's really simple. If you don't know about Redis, it is just it's a key value store in memory. So I can just spin one up. Actually, I'll probably spin one up before the end of the stream. And I'm not super familiar with how to use it in Rust. I've used it at a previous job, and places where Redis kind of shines was being able to set like lifetimes to the not lifetimes like in Rust, but like you're able to keep like a session time for the key itself, and if for whatever reason like you don't touch the key and the session time expires, it kind of goes ahead and it deletes itself. So that's kind of nice, and I probably envision that that's one of the ways that we'll have rooms where we're able to keep room information and like what's going on in there, and we'll keep like all of the game data in the cache, and any like rooms that are created are just going to be stored here. So when the client creates a game, the game will ask for a room code for the server, and the server will just generate a bunch of room codes until, well, it'll just generate one, see if there's a collision. If it's not, it'll return it to the game. Otherwise, it'll store it in Redis, and then that's what gets displayed to the client, and the client will be able to share that to, well, the game will share it to the clients that are playing the game, and then they can all join the room. And then once we're gonna have some state logic. Server. So we need some state machine for the game. And that's like outside of the game logic, because we want to be able to move from being in a lobby. Maybe I need to implement the lobby. Create a lobby for pre-game so one of the things that you'd want to be able to do in the lobby is to kind of sit and wait for players to join, like kind of give a name and stuff. And that's kind of the same as send game state for. I'm not gonna clean this up yet. This generate room code. I didn't tag this for this for the domain. The game board. What did I mean by that? connect to this server. Display the room code. Show connected players names. Okay. So what I'm probably gonna do first is create the server. I want to start from one end. I can create the client or I can create the server. The server is a little bit more in my domain, so I probably want to start from there. And I can do some of the DevOps stuff now because that's simply just creating a Docker Compose file for infrastructure. Let's be more specific for Redis. And eventually I probably want to have like a Docker file for building the server and running the server. But I'm going to leave that near the bottom. Create a Docker file for running, for building and running server. Just keep that at the bottom. Okay. What did I mean by creating a server? I guess I need to determine the client server tag. I don't really know the pros and cons of WebSockets versus GraphQL, so I guess I can do a little bit of research here. Okay, so we can design some of the state machine even before. Let's design the state machine first. Creating a doing column, and so that's just I'll just leave this here. We'll create a done. Okay. So yeah, we can do some of the state machine design today. I just want to make sure that I have at least a little bit of the design set up in the Kanban board. Create a server. I need to be more specific about creating a server. well, and then create a lobby for pregame. What do I want for creating a lobby for pregame? This will probably be generating the room code, and then leaving a let's call it a reference in Redis, an expiring reference. And so the expiring part of that is I don't know, we can set a timeout of like if in 15 minutes, 20 minutes, like if someone doesn't actually do anything in the game, or if the game is not connected and is actively letting the server know that there's someone in the game waiting, then we can exit. Game, rock paper scissors logic. Connect to the server. Did I have sending game inputs, or because the client needs to be able to say rock paper scissors. Nope. Send say rock paper scissors input. And the server needs to keep score. Per player. This is a really weird tool. Like, not exactly what I'm expecting it to be. I mean, I guess this is useful for somebody, but I don't know who yet. Okay, so I guess we would be able to create issues. That could be useful. Okay, I don't even do that. Move this to the bottom. I'll organize some of this by order a little bit later. But let's go through what we've got. So, creating a Docker Compose for Redis. Choose the server, client server tag. Create the server. Create a lobby. Generate the room code. leave an expiring thing in Redis. Server create send game state to all connected clients. That's a lot. That's a lot abstract. I'll probably need to expand that later. Connect to server. Add Redis. What do I mean by add Redis? I will generate room code. Create keys in Redis. By room code. Store game state. For game state. And store player names. And I'm gonna need to have some hooks for the game board to actually. This will probably be the server. So what is the game board? Just the view. The game will need to get the current users. Game will need to send inputs to the server. And I figured that I'm not gonna have the game board do any kind of logic, even though in this case it'd be really trivial for it to determine who's winning and losing. Send get current users from server. Game needs to get the scores. Okay. I'll leave that near the bottom. I'm getting the feeling that I'm probably gonna do the view last. Because it's highly dependent on a lot of the interconnecting networking, either if I'm doing graph or WebSocket. Yeah, I've been talking about that a lot. Let's put that on the plate too. Choose. Okay, so let's do the state machine design now. How do I do it? Okay. What am I calling this frame? This is the high level design, high level networking. Oh. Okay, and next will be the state machine. And so this is the state machine that the server will take. No, the game state machine. And so the first thing that we'll do is we'll start the server. And then after we start the server, we'll create a game. And this is probably the client initiated. The client will request that we create a game. Oops, how do we do arrow? So when the client creates a game, let's probably do it in separate columns like it was before. Let's create even more structure here. The server, I'm going to create myself like a little pseudo swim lane. Server, game view, client. And so when the game view is loaded, we will ask the client whether or not they want to create a game or join a game. And so we're probably going to go through the creating a game portion first. Create a game. Okay. So when we create a game, we'll do this all at one time. Okay, and so after we create a game, the server generate a room code. it'll check for collisions of the room code. Check for collisions, and I'm gonna leave a star here because there's more than just collisions. We want to also do some checks that it, actually I'm not gonna worry about that now, but Jackbox, they do a filter to make sure that their room codes don't say anything offensive. I don't really care right now. I'll leave a star there. And then I need to draw a little, man, I did this before too. I need to draw a little circular arrow. Do it like this, is that right? How do I? Neat, cool. That's what I wanted. I need an arrow though. So how do I? No, I just want one side. Numbers and letters in the code. It'll probably just be numbers, or just be letters. It'll, I mean, and capital letters at that, because it'll just be easier to distinguish what is what. So that probably should get put in the code here. So let's say 4 characters, letters only. All caps. Oop. Let's make that the same type of arrow as everything else, which is not the triangle, the line arrow. Okay. Neat. I only did that once before. It's kind of fun that I remembered how to do it. Oh. Okay. After we get the room code, check for collisions, we'll send it back to the game view. Oh, check for collisions, and then one more step before we give it to the game. We should store it. Or reserve the the room code. And then we will return that back to the game. Display room code. And at that point, clients can join the game. So we can probably keep it all here. Now, how do we actually, the way that this would work is the client would connect directly to the server. So a client would request to join by room code, and it would just do that directly by connecting to the server. I think. Display room code, so it would say update update player list. All right. So yeah, when a client requests to join the game, I'll leave a little bit of a note here because I do want the ability to have a maximum number of players eventually, but that's some other logic. Check room capacity. And here we'll just say, assume this is the good path. Pressing this button a lot. I can press L. Okay. Uh, How did I do that? Keyboard shortcuts, neat. That's just a line. I wanted a line with an arrow, which is Shift L, capital L. So after a client requests to join the game, we'll check the room capacity, and then we'll say the good path. So I will just let the player join the game. Add player to the game. So that will happen at the same time. Or I can probably just add the bad path here. So what I'm doing here is, if the room is at capacity, we'll just send an error message to the client. Leave it here because it's an error state, and I don't necessarily know how to visually communicate that. Okay, so when a game has players in it, let's be more specific. So a host creates a game. And then a player joins a game. Check room capacity, add player to the room, update player list. So player in lobby. And then while everyone's in the lobby, we're just waiting for the host to start the game. I will probably need to split this client part up in a minute, but I will keep it all here. So the host will start the game. And we'll do that just by communicating directly to the server. Okay, and with the host starting the game, let's make this a little bit bigger because can't see it. All right. So with the game started, one of the things we don't really have is the actual turn logic. So let's add that to the list here. The server needs the player turn logic. And we'll design that in a bit. And I'll leave a little note for it here. So we'll determine who goes first. And if we're going Jackbox style, we're basically just everyone's going to be sitting and watching people play at the same time rather than like going all at once. Determine first match, and then we're going to be in the game. So we're at this point we'll have players and spectators. Oh, I missed the entire part where the view needs to be updated. Instead of first match, let's say next match. Because this is going to be more or less a loop. Then we're going to have two different views. So we'll have the spectator view and the player. Spectator view and the player view. And so this will be our little loop here. Okay. So host starts the game. We start the game. We determine the next match, and then we send out the different views. I feel like that's taking a little bit too many shortcuts. We need to tell the client what view is up. Whoa, why are you not selecting? So determine the next match, and then we want to tell a player that they're next or that they're watching. So player is watching and player is playing, I guess. It's not great. Player is playing. And we'll just tell the client side, like, all right, you're playing or you're watching, and then if a player's watching, they'll ask for a spectator view. And if a player is playing, they'll get a player view. Either way, the game view will need to know who's up. We'll get the player, current players. And in both cases, we'll put that in both of the views. We'll say return. Or, yeah, return both the current players. Okay, and how does Jackbox do it? So Jackbox, they pretty much synchronize inputs with time. So we'll start a timer. We'll need to tell the clients that we've got a timer. We'll just like leave that timer in the view itself. All views. So in all of the views, we'll have the timer going down, and then the players will input. Send. Or they can even send no input, and the server will do something. Sender player send input, and receive player input. We'll get the player input. We'll wait for all inputs. Wait for all inputs or timeout. And then when we time out, or yeah, when we get the time, let's go through the player inputs all coming in. Actually, let's do the timeout since that's the easiest one. So on timeout, we'll just have some logic here. Determine a winner. Or draw. And store in store a result. We'll calculate the winner. Quote it, calculate the winner. And then we'll just update the view. Got the we'll call it the current state. Get the current score. And just update. We'll update the scores. That's where we're going to get all the state. Update. So store results, store score. And then here we'll just update the score on the view. And what's next? Start the game, determine the next match. Start the timer. We wait for inputs, wait for all of the inputs to come in, wait for the inputs to come in and either timeout or we on all inputs. Store the score, and then update the view where we update the scores, and then start the next round. Start next round. Okay, and I just leave an arrow here. Line arrow. I bet that didn't do what I wanted it to do. The wrong side. Line arrow. Is that not doing what I want it? No, that's just real small. Okay, that seems to be what I wanted. Start the next round. So that seems to be the that's rock paper scissors right there. I believe. Start the game. Next match. We tell a client that they're watching, or we tell them that they're playing. Then we update the views accordingly. Views say who's playing. We start a timer. The players send their input. The server waits for all the inputs for a timeout. We calculate a winner. We store the score. We update the view. We start the next round. That there's the next round, or we end. End the game. End the game, and then we just display a winner. Okay, that seems to be the end of there. And the host can just play another game, I guess. Play again with the same players. And this will probably also just do the play again with same players. So here we'll have the server clear game history. I guess I'll leave a little star because I don't necessarily know what that means. And then we'll determine the next. Cool. And there we go. Line arrow. I think that shows it. Yep, that shows it. I think that that shows the entire thing that I can think of at the moment. So for rock paper scissors, that seems like it will say that that's done for now. We'll do this one research thing now because I don't necessarily know what it is. Let's just do some quick Google searching. WebSockets versus, I don't know, GraphQL. When would you use REST WebSockets and GraphQL? So maybe I'm not thinking about this correctly based off of how this is answered. When would you use REST versus GraphQL? When would you use HTTP or WebSockets? The way that I kind of thought about it was that WebSockets is like a TCP connection that would have like an open two-way connection, and I kind of thought that GraphQL would be sort of that mechanism for stream, but based off of how GraphQL works, it would also have a structured query or structured. I mean, not technically, but like it would have some kind of typing involved. Right. All right. That doesn't really feel helpful. So this person is how you manage 1 million GraphQL WebSocket subscriptions, and then I've already used all my free. Sorry, Medium. I'm not gonna pay at this moment. Am I thinking about this wrong? Like maybe I would use GraphQL in with WebSockets. So how would that actually look like? WebSockets, GraphQL, WebSockets. Real-time GraphQL subscriptions. So how to GraphQL. GraphQL is better than is the better REST. I can go through a little bit of this. Subscriptions are a GraphQL feature allowing the server to send data to its clients when a specific event happens. That's what I want. Subscriptions are usually implemented with WebSockets, so I would use, in this case, I would use GraphQL with subscriptions. That sounds right. Where the server holds a steady connection to the client. This means when working with subscriptions, you're breaking the client response cycle that was used for previous interactions with the API. Now the client initiates a steady connection. So how was I thinking about this? I was thinking about this with in accordance with Juniper. So Juniper is a Rust client or a Rust server client for GraphQL. Juniper WebSockets. A better way. Well, I'm not looking for a better way. I'm just looking for a way. So their examples have subscriptions. I remember this actually when I was playing around, but I didn't quite understand what subscriptions were. So now WebSockets. That's the open connection. Cool. Yeah. This is a little bit. I'm not ready to look at this, but that's there. Um, so client now initiates a connection with the server by specifying which event it's interested in. And I don't know that my state machine was amazing with the event definition. So let's define events for clients to subscribe to. I'll say subscribe. I'm kind of like in the mindset now that maybe I'd be using GraphQL. But let's not discount it yet until I look into what else is available with WebSockets. Yeah, okay. I can connect, and then I would want to know how do events work. Well, I want to be able to have my own events. What is... These are kind of like browser semantic events. It's not what I'm thinking. I'm looking for a game. So this is about WebSockets, long polling, server sent events. So what am I doing? I'm looking at server sent events, I guess. How does that actually look? Well, WebSocket, so bi-directional communication, that's what I want. So they don't use XML HTTP request. No headers every time, so that's good. So stumbling blocks, if connections are terminated, they don't automatically recover. I don't necessarily know what that means, but that's kind of a problem for if like a person leaves a game on accident and they wanna come back in. I know that Jackbox does that really well from my experience. SSE, so it's over HTTP instead of custom. Built-in reconnection and event ID. So it does not support binary data. I don't know if that's necessarily a problem for me. Maximum number of open connections per browser. That's not really a big deal. Monodirectional. So I probably would still want to use WebSockets. I don't think that server sent events was ever on the list. Okay, I guess another way to look at this is through what libraries I would use for REST. I'm pretty sure that there's a WebSockets framework. Cool. So here they're talking about don't want to probably read this in a bit. A CRUD web service with Rust and Warp. Okay, WebSockets. So here's a setup. All the dependencies, anything in here. So pretty much everything here I know well enough. Tokyo, Warp, Serde, Features, UUID. That's straightforward. Yeah. Data structures. So our client has an ID. Topics, which we'll get into that. And then what is this? Sender option result. So we have ourselves a little channel. I'm familiar with that MPSC library. So the difference between a client and a user in this case, a user can have several clients. Think of the same user connecting to the API using a mobile app and a web app. All right. Register request, register response. That makes sense to me so far. Topic. What is topic? Did I miss something because I was skimming through? Topics they're interested in. Sender is sending part of a channel. So I already know that. It's used to send messages to this connected client. Next data structure is used in the REST API for registering users and broadcasting events. We probably won't be necessarily doing this because we're not going to be doing much registration in our game. It's more like someone logging into a room and the room is temporal. We need a way for clients to communicate to the topics they're interested in, but we don't see set the topics explicitly. They'll be defaulted to cats because who doesn't love those? Yeah. Getting the server up and running. Now that you have a mental model, let's start by spinning up a warp server. All the routes we need. Okay, so here what do they have? They have two modules, which they're not in here. They wrap the result. They have a type of client, an arc. So clients, then they create a health router. They create a register path, and then where does this register come from? Oh, from here. Register and post and body. So I don't know the warp crate that well, but this seems like so you can post to register and then take JSON input with clients, client clone. So we're just cloning our clients in here, and since it's in the arc, that makes sense. Or register, warp, delete, param. So this one, you can post or you can delete. Publish says you can take in the warp path, body JSON. And then here's the WebSocket route. Warp WebSocket US path param. Is that just like a form? I guess that's what I'm thinking. And you can pass in the clients and then a WebSocket handler, and then health route. That's convenient. Warp is pretty straightforward. So you can register health or what? Or path health, and then health handler. So what I don't understand in Warp yet is how all of these register route, like this OR stuff works. With cores, allow any origin. So okay, with all the cores, serve all of the routes. Health route or I'm guessing that means that health route is the default. And then or all of these, any request, then we run it and we await with clients. So with clients, it takes in clients. We use that here, where it was with clients. So we pass in with clients. And we return an impl filter where I don't know if the filter trait, but we extract clients, and then I know what infallible is just from looking at it, but I don't know what it is. We need something that implements filter and is clone. Warp any map, so we move the clients. Oh, we just clone them, I guess. Okay. Well, they step through it. So we want a lot of people. So just updating people since you guys are noticing that people are coming in. I'm making a game. Doing it in Rust. I just went through the Kanban. I went ahead and I made a Kanban board. Right now it's called Untitled Stream Game on my page, and the basics of the game is I'm making a little Jackbox clone, and I walked through. I'm using Figma and I walked through kind of a state machine type design for the game. The high level networking is here. We just have like a client and it connects. It connects directly to the server. But we have this game state. You know, if you're not familiar with Jackbox, you can just use your browser and get kind of the view of what the game is like. And then the server will keep all of the game logic, and we pass. We're making a rock paper scissors game because I figured that would be simple enough from a game logic perspective. And yeah, like it's pretty straightforward from a game's perspective. I kind of wanted to keep the whole. We have a host create the host creates a game lobby, and it generates a room code, and then people can use their phones or their browsers to connect, and then the host will start the game, and there'll be some kind of like rock paper scissors round robin or some. We didn't determine that, but there'd be some kind of strategy for people playing against each other, and at the end we'll calculate the score after everyone's played against each other, determine a winner, and then host can say like, do you want to play again or not? You know, do it once or twice. Be kind of fun. But right now, I kind of I wasn't sure how to do the interactivity half of the game. I didn't know whether or not to use like, as someone who mostly does backend stuff. I kind of thought that it would be between like using WebSockets or using like GraphQL, but some of my research is showing that you might use WebSockets with GraphQL, or you can just use WebSockets directly. If anybody knows or has a preference or can give me any kind of shortcuts for how to think about this, I'd truly appreciate it. But otherwise, we're going through and doing some research on that. So I guess some of the how I got to this mindset for the architecture is from an AMA that I saw on Reddit when I was doing some research prior to this stream, where the Jackbox game devs, they came in and they talked about their stack, and they basically create their own game server. They call it Blobcast, and it's just a bunch of Node.js servers that it pretty much, like, I tried to emulate how they described it, where it's just a bunch of state that they keep in Redis, and the game controller is there to be as the in-between to talk between the server and the view, and then the clients just connect directly to the servers. So I think on that note, I'm gonna try to do this all with like a web app kind of architecture for now, and I don't really see any reason to make it any more complicated than that, for especially with such a simple game. But I'm kind of itching to write code. Probably not in this stream, but I really like to be able to. But I don't really have an appetite for trying several different things. I kind of want to pick one and stick with it. Okay, so back here, this is talking about WebSockets and Rust, a WebSocket server. So yeah, when I was looking at, I was just kind of picking apart the server that they've got up here. They got a bunch of Rusty stuff, and then they have this one section for WebSocket, and I have that here, so I can walk through their description a little bit. Okay, so besides all that, except for the WebSockets one, it's all pretty basic. The WS route filter is used, so it makes it possible to upgrade the connection to a WebSocket connection. And at the end, the routes are combined into a router with cores. Service are in 8000, is that correct? And then client registration. So with the server set up, let's look at the handlers. So this is the handlers part. Let me double check, because I think that was one of the modules that I saw and I didn't see. Yeah, so they got a handlers module, and I'm guessing that's this file. So we register handler, take in a body or register request, then we take in so I'm guessing that is a form. Get the user ID, we generate a UUID, and then we call this register client, we do an await, and then we return a URL. So what does register client do? It what is clients again? Clients is a yeah, it's an arcmutex hash map. So the mutex part. So we lock, we await to add to the mutex, or to add to the hash map. Okay, so everything is kind of kept inside. Kind of questioning whether or not I need to keep things in Redis at this moment. I can do something like this. I wouldn't. Yeah, no, I'm probably gonna keep it in Redis still, because I would have to filter through all of this, and even if it was just like one game or like 2 games, it'd be a lot to sort through. I just want to be able to query from Redis to to keep that kind of information in there. All right, so okay, so they create the UUID for a client, and then they add them to the client's data structure, and they return the WebSocket URL. Yeah, to add, they need to get the lock for the mutex, and then they can await on it, and when it's done, they just return. Is that what they do? No, this is just. What does this do? Okay, they just await on it, but they don't return anything. Oh yeah, because they're passing in clients, and that's already an arc, so they don't actually need to worry about passing it back. Okay, so they can register an endpoint like this. Right, so they can register a client. How did you connect? Okay, so if you're already connected via WebSockets using this ID, simply disconnected, and everything is closed and cleaned up on the side of the service. So this works because removing the client makes it go out of scope, which means it gets dropped. In this turn, the drops the sending side of the client of the channel, and which closes the channel, triggers an error, which we'll see later on. This is a signal we can use to close the connection. Connecting via WebSocket. That's something I don't know very much about at all. So now that clients can register and unregister, let's let them connect to our real-time WebSocket endpoint. Let's start with the handler. So they take in a WebSocket, they have an ID, and then they pass in the clients. So here they wait for the mutex, and they get the ID, get the client. Match client. So if there's something there, oh, okay. So if the client is still there, then there will be an option, and then they can return an upgrade move socket. So here's where they upgrade this socket connection to the WebSocket. All right. Okay. First, the given client ID is checked against the client's data structure. If no such, a 404. If a client is found, WebSocket on upgrade is used to upgrade the connection to a WebSocket connection. So when we have the WebSocket connection, it is split. So this is the core part of the WebSockets logic. Step through it slowly. The function gets a WebSocket passed into it by the warp filter. What are we missing? You can loosely consider this upgraded WebSocket connection and an asynchronous stream in sync. The split function of the feature stream splits it up into a stream and a sync, which can be considered a sender and a receiver. Now we create an unbounded channel which can send messages to the client and also receive. So the client sender is exactly the sender part. Yeah, that makes sense. So client receive forward WebSocket sender. So next steps is to spawn a Tokyo task in which the messages are sent to the sender as part of the client. Client receive are propagated to the sender part of the WebSocket stream using the features stream ext forward. If the message then fails, then we log. In a different scenario, it could also be feasible to close the connection depending on the error. So the next step is to update the client with the newly created sender. Where's client? Client? Where is client? So I don't know if that's a typo or whatnot. Oh, this is still the same file. I don't know where this client sender is equal to some sender. Client's locked. And then they insert this client into the client's arc. Pass-in client gets the sender part of the sending channel and the data structure is updated. From this point on, if someone sends anything to the sender end, it will be forwarded to the client via WebSocket. So we will log the client as connected. Now that we can send to a connected client, we also want to receive. First of all, the client should have the ability to send us pings. Check whether the connection is healthy, but we also want to enable clients to change their preferred topics via WebSocket. Okay, so here we are listening onto the client receive WebSocket. And then we destructure it if we find something, and then what do? We print to standard error, and we print the ID if it fails, and then we break out of this loop. Okay. Client message. So then we await. Did I miss where client message was? It's probably not there yet. Oh, which we'll look at next. Yeah, so interestingly, if an error happens, the error is logged and we break out of the loop, which leads to the end of the function. But the only way to get there is to error out. And then if that happens, then we've removed the client from the data structure. Right, client message. So to finish the WebSockets part, let's look at the client message function, which deals with incoming messages. Hello, new people. Right now I'm just looking at some WebSocket stuff since I don't know very much about it. If anybody knows anything about WebSockets, especially like using it in Rust, like I'm doing here, let me know in the chat. I'd be happy to listen learn. Right now I'm getting to the bottom of this walkthrough. We're looking at the WebSockets part. Messages ping. So this is if a client wants to talk to the server. You can do ping, or you can, what is this? Topics request. So each message is logged. Then we tell the message to convert into a string. If the message is ping, it just returns, doesn't say anything, usually pong. Here it is. Other kind of message is if a topic request. So if it's a topic that they want to request, then they match from string. So they try to see if they can pull some kind of topics or parse some kind of topic out of the request based off of the message. And if not, it errors out. Oh yeah, so it errors out and then it removes the topic. Is that what happens? Other kind of messages. So when a client wants to change their preferred topic, to do that, they have to send some kind of JSON to the WebSocket that's just parsed out a list of topics. And this is updated in the client's data structure. From that point on, the client will only get messages according to their topic preferences. So WebSockets are now available. So I might be able to do something like this instead of going through the entire process of using like GraphQL or Redis, and there would just be a bunch of so I'm kind of leaning in that direction. I think I would need to update the drawing just a little bit, but it seems good enough to keep the cache. WebSocket. Oh, I need to look at that. Install that. So I was wondering how I'd actually test the WebSocket. Relaying messages to clients. So the only piece of the puzzle is they're missing the ability to push, and that's broadcast messages to connected clients. This is done using the publish endpoint, and that's probably what I would want to do. How I'd probably want to create a WebSocket based off of the room code, and then I'd have clients connect to that, and then we would probably push from there. And so I'd be able to just have threads, one per game, where they'd be able to just push to the clients that are connected. A little bit weird. It's a little bit hard to keep in my mind. I need to draw that out. Whenever anyone wants to broadcast a message to clients, we have to iterate through the client's data structure. If I don't know if that's a typo or if that's intentional, only if a user ID is set, filtering out clients that are not specified, not on the specified user. we're only interested in clients that are subscribed to the topic of the message. So, so they publish anybody we can call like that. Message will be sent to a to connected clients with a user of 1 subscribed. So this is them sending a message. That's interesting. So this is a pretty neat tool, but it's not what this has been really helpful. I'll probably go through this off stream, but this seems also really useful. A crowd web service and REST with Warp. It's not exactly what we're doing right now, but that's an interest. 2007. Okay, so I think based off of reading this, I at least want to try to just do this with WebSockets, and I can graduate to GraphQL if that seems to be where the complexity seems to balance out. Using WebSockets based on perceived difficulty. The first time. GraphQL if GraphQL plus subscriptions are still available if I needed. Right. I'm not sure if I'm gonna need this Redis thing still, but I'll leave it there. I'll define events for the clients to subscribe to. I think I'm still too early for that. Player turn logic. I can probably I want to do some coding, and that seems like it's pretty simple. Let's just do that now right here, and then we'll probably end the stream after that. Move you to the right. Increase some of the text. Okay. Just that we'll have thanks. I started looking in at other streamers, and I'm seeing that they also kind of go through their design process, and I feel like if I'm gonna do it anyway, I mean I can take some tips on making it a little bit more entertaining, so it's not just me speaking into the void, but I'm happy to do it, happy to kind of show my process, especially since we're all just learning. I feel like if I can give some context there, it helps everybody. Oh shoot, I forget what. Rock, paper, scissors, hands. I don't know what the rock, paper, scissors. Yeah, definitely designing and making choices. Naming things is probably up there with like making choices for design, like intentionally. Like right now, it's rock paper scissors options. I'm not sure. um, I'm gonna. I feel like I should just write a test for it. Um, so wish that I knew how to take a random of an enum. So right now I'm just gonna like say uh layer 1, 2. Well, I can player 2. I'm player 1. RPS. Yeah, I mean the thing with naming things for me is I hope to make it descriptive enough um without kind of getting into like Java land where you get like 30 character identifiers. Um but hopefully you're able to get some kind of context for what you're doing. Yeah, making things flexible for the future. Sure, that's where I'm going for it. Absolutely. Um, yeah, renaming things is useful, especially if you're using the right tools to make it easy, and so you don't have to. And all of your naming is done inside one encapsulated place, so you can actually just do a like a careful search and replace. But um, yeah, of course, I agree with you don't have to avoid if you can avoid it. That's my preference. So what I'm doing right now is, I guess I don't know an easy way to do this, but I'm just gonna enumerate through all of the different combinations. Oh, um, so rock, And then two wins. Scissors. Player one wins. It doesn't need to be player specific, but well, let's think about this a little bit. I mean, it kind of need it. It's equal to draw. That's true. I think that the way that I would do that is it's kind of an implementation note. So if it's all equal, and I see the reason. I think what I'm trying to do is I want to be able to like distinguish a player one and a player two and kind of feed them into this function, and then pick apart. So like definitely it's easy to say if they're the same then it doesn't matter, but then I need to distinguish who's a winner. Parsing this, starting. I made the terminal go away. Projects you can call out a specific set, so there that I mean I suppose you can do that. I guess what I'm trying to do is not really, I don't need to make this elegant as much as I can make this clear, and it seems very clear that if they're the same it's a draw, but otherwise I can I mean, it's not just 3 cases. It is what three? It's 9 cases, right? But I can establish that that the when they're equal, they're going to be there's a clear draw there. Um, I got a little bit stuck because I wanted this to compile. So right now I'm just trying to make it format. I am not sure why this is upset. Remove the... So I'm going to look this up. Match this. So I think that it doesn't like it being on multiple lines. Oh, it actually is complaining about just this one, this last one. Okay, but formats again. Uh, hold on a sec. Scissors, scissors. So for rock, paper, scissors, 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 paper. So in all of these cases, it's a draw. Otherwise, 2 wins, player 1 win, player 1 wins, player 2 wins, and then here it's player 2 wins, player 1 wins. So I can play around with this. Cargo, run, draw, and I pick a random in the enum. Rust, random, enum. Well, it doesn't look like it's going to be super straightforward to pick, but I guess we can play around with this. So rock, paper. So player 2 wins. Is that correct? Yeah, so player 2 is paper. Player 2 would win. Scissors, player 1 would win. Paper. So here, player 1 would win. Scissors, player 2 would win. Right. If this had more than 3 options to choose, I definitely like want to find some other programmatic way to do it, but I also don't want to overcomplicate it for the size of this problem specifically. And it would be repetitive, but it would also be very straightforward is probably another way to look at it. Like at least like what one of the things that Rust makes you do is like if let me show, like if I delete this one case, it will complain for having not covered all of the cases. So like it knows that I didn't cover all of the cases. The scissors paper instance isn't covered. And so in this case, since there's a very direct balance to everything, like at least being really explicit with that, with like defining how that works, it's at least really clear here. So if I were to decompose this even further, having the relationship of rock and paper and scissors will be really important, but then assigning like the equality and like who that belongs to is another, it's like another way to another place to simplify, I guess. So in this case, I'm doing it like this because Rust makes me make it all exhaustive. Okay, so since this is here, I guess the last thing I need to do is throw this into a function. We'll call it like RPS winner. Winner what I want. And so call it P1 and then RPS option P2 this option, and I'll just return a string for now. So we'll return all of these print lines and turn it into format. And I'm definitely thinking about how to decompose this a little bit further so that I don't have to worry too much about the whole like player 1, player 2 thing. I probably need to create some kind of structure for player. I could probably do that now. Let's do this one at a time though. What I'm going to do here is the winner is then I will call RPS winner player 1, player 2. And winner is player 2. So I guess the last thing to do is to create a struct and then player and we'll have an ID and that will be a I don't know, an int date. Can't remember how the U8 and your hand. It's going to be an RPS option. And so what I'm doing here is I'm just creating some, so instead of the winner will have some sort of identity instead of just a hand. ID 2 and rock. No ID on RPS option. Uh, one. And so what I'm doing here is I just need to return the actual player. I'm curious though, how would I do the draw? I'll just say that ID 0. You know, this is just me figuring things out for now. Doesn't matter. S. Player cannot be formatted using that. Let's add derive bug. Capital D debug. Same with What am I missing? Mismatch types. What did I miss? Expected struct. Found RPS options. Well, that doesn't make sense. Well, hold on a sec. Oh. Value here, use after partial move. I feel like I'm going to need a derived clone. Ah, that was fast. All right, so this seems like we're nearing the end of what I'm trying to do here. This seems like in absence of being able to create a random in a short amount of time. It looks like the game logic for now. So we just have a hand here. We've got a player, they've got an ID, and they've got options. And so I just defined 2 players. And then this little check for who's won. So if we pass in the same hand, then right now it just says 0. And I need to add something here, such as this rock. And then otherwise we do some checks. If player 1 passes in rock, and then pass in paper, and then player 2 wins, and then rock and scissors, player 1 wins, paper rock, player 1, paper scissors, player 2, scissors rock, player 2, scissors, paper, player 1. I will check that in. Okay, where's my I'm gonna call this done. Okay, so we did a little bit of research, mostly research and design today. Needed to get some code written so that I didn't feel like was completely drained from all the designing, but that does seem like a really good use of time. Feel like I'm gonna be doing a little bit of extra research, but we got ourselves a little bit of a to-do list. So next week I will continue on this journey. So Wednesdays at 12:15. Come check me out. Follow me on Twitter. I announce when I'm doing things. And cool. Thanks everyone. Signing out. Bye.